Hello learner, welcome to Manifested e-learning platform. My name is F.A.M. Lingwiri, and today, ladies and gentlemen, we are discussing about the business and data analytics April 2023 question 22. It reads as follows: you work as a management accountant for Majani Limited, which deals in tea production and export. Before embarking on next year's budgeting, you are tasked with analyzing past revenue and price trends. As a starting point, your supervisor has provided you with historical price and production data as shown in the worksheet. So you can see the dates have been given to you, the production, millions of kilograms, prices per kilogram. We move down and see what we are required to do. A. Plot a line graph for price against time or dates. Insert a linear trend line displaying the equation and R squared on the chart. Briefly discuss your results. So we go back up here and pick the relevant data. We start with the dates, move down like so. Then we go back up again and pick the prices. But before we pick the prices, we need to press Control so that now it can jointly pick the dates and the prices at the same time. So you can see as I press Control. Then you hover around Insert, click on Insert. Then you come to Line Chart. This is what to say the line chart. So you click on it. Then you proceed on to click whichever chart pleases you amongst this list of for line charts. So let me click on the first one. So as you click on the first one there, we just need to just be patient a bit so that now the output like so can actually come out. So what we do, we just place this where it's supposed to actually be, next to the solution, ladies and gentlemen, there. And moving like so would mean that we would be able just to place the data where it is actually supposed to be, which is right over here. So what are we told? We are told that we need then to plot the line graph. That's okay, we've done that. Insert a linear trend line displaying the equation and R squared. So we need to display the equation and R squared. R squared represents the coefficient of determination. Coefficient of determination assists the investment expert or the accountant to identify whether the regression is reliable. So we go back up here and we just right click on the graph. We add a trend line right here, and when we click on this like that, the trend line should be able to appear. As you can see, moving towards the right here, the trend line appears. We can then now display the equation. So you can see all of these inputs over here. There's either exponential, there's linear. Linear is what we've been told that we need to do. The trend name, we just say it is the linear price per kg, which is okay. Then we move ahead and say that we need to display the equation, which is there. We tick that. And then we also display the R squared over here. So we tick that. That's what we've been told by the examiner. And then we can close this part here, close it. And for a clearer picture, we can place the equation just above there like that. And then also what is going to appear is going to be the R squared. Now that's much clearer as compared to where it was initially placed right there. So this is our part A. We can then move ahead and try and identify what we've been asked for part B. For part B, we are told using a suitable MS Excel function, show that the coefficients shown in the trend line in A above are in fact a result of a linear estimation between historical prices and time. So what we do is that these what is called a leanest function over here. So we move this over here like this. Say this is part A. Like that. So we can put over here part B. And we now use the leanest function plus leanest. So what is leanest? We are saying that the leanest represents linear estimation in full, and this value returns the statistic as it's shown over here. It returns the statistics that describe a linear trend matching known data points by fitting a straight line using least squares method. So what we do is that we then now need to identify what our y value is. Our y value represents the prices per kg. So come over here and highlight everything there for known y's. That. And then we go back up. Our known x's. Our x's are influenced, are the what we call the independent variables. They're the ones that influence the y's, saying that the dates and the production in kgs, we highlight both of them together like so. And then clicking on this part over here called constant here, it represents a logical value. And we say true over here. True. That. And we say okay. So we are told that an unexpected error occurred. So we just click OK here because we are saying that we are getting negative 0.74. And this is the formula for the linear estimation. So linear estimation right here. And we say leanest. Like so. Leanest. We can be able to put it like so, and put it in form of maybe say perhaps maybe you can be able to just highlight maybe in a different color and maybe just for presentation purposes there. So you can put it like so. Then maybe you can proceed on to put it in form of a thick square outside there. So we expect that this 0.7412 should actually be the same as the value right over there from the equation. So moving on, we can then move on to part C. Part C, you can see that you know that prices are affected by production. Because of this, you would like to run a regression between price, production, and time. Use data analysis tool pack to run regression analysis, interpret your results. Be sure to discuss the coefficients and the parameters. So what we do is that we run a regression, part C here. Like so. And then we pick the dependent and the independent variable. So the data analysis tool pack is under the data tab here. Click on data. Then on the far right, you can see data analysis. Click on data analysis. And then you search for regression right here. You can see regression is right there. Click OK. What is our Y input range? The prices. So we click the prices like so. And then our X input, click there. We go back up again and we can see that both the dates, this is a multiple linear regression, the dates and the production levels are the ones that influence prices. That. So if perhaps you would want the labels, be able to put in labels over there like that, and then we click OK. So we have this output. So you can copy this output right over here and place it as appropriate on question 22 right under part C here. Control V. And we are saying that we can be able to see these regression statistics, R squared, which represents coefficient of determination. The standard error has also been given. We also have number of observations, so 154. That. And here is what we have as the intercept right here. We have the intercepts right over here. Then we have the dates over here. So you can change this to dates. And here you can be able to say production and millions per kgs production. Kgs. That. When x is 0, what is the value of y? Then that's what is represented by the intercept there. The dates are coefficients that influence the prices, the dates as well as the production in terms of kg. So we are saying that you can see this is the intercept and the date and the production per kg. That. Notice that under leanest over here, we expect negative 0.074. That. So 0.074 should be the part of the intercept right there. We can now move on and understand or analyze the p-values here. Come to home and we come like so, we do like so. We are saying that low p-values less than 0.05 means that the coefficient is likely not to equal 0. But if we have high p-values greater than 0.05, then we are saying that we cannot conclude that the explanatory variables actually affect the dependent variable. In terms of the F statistic over here, we need to look at the F statistic in collaboration with the p-values. The F statistic, or rather, when you're saying that because the p-values over here are greater than 0.05, with the exception of this production of kgs, then the model might not be reliable for analysis, or might not be used for analysis. When we look at the R squared, our R squared is given to us right over here. I can highlight that over there. And we're saying that we want our R squared, if R squared is greater than 0.95, then the regression should actually be reliable. In our case over here, it is not greater than 0.95. And hence the model is not reliable for analysis. It cannot be used to predict the future production levels. So what can we conclude from that analysis? We can conclude that the model is not good, because we are saying that the R squared is not greater than 0.95. Secondly, we are also saying that the p-values right over here, because most of them are actually greater than, all of them are actually greater than 0.05, all of them 0.05, we are saying that we cannot conclude that the explanatory variables actually affect the dependent variable. We can also conclude that innovations can be, for example, to remove this constant value over here, to try and evaluate and estimate if the value is okay, or we can be able to use other metrics or other time series data to analyze or make inferences of this data that we're analyzing towards our left. So that is it for question 22. We hope that you have enjoyed it and you've understood how to run a regression. Thank you for being with Manifested Publishers. Be blessed.